Hi, welcome all. So this edition of DevDay. DevDay is a occasional dev catch-up here at Sahaj. It's not just for Sahajivis, it's for anybody who is interested in fiddling with technology, involved in development or implementation of solutions. So we discuss about various challenges or like new technologies that is coming up, sharing experience. So that with that, like this edition, we would like to start on the mental models used in the a large-scale digital certification platform that we got a chance to work on. So I am Dileep, solution architect, Sahaj.
So myself, I'm Tejas, and I'm part of Sahaj as a solution consultant for last 5 years.
Okay, with that, let's kind of get started. So Divok is an open source software platform. It has been identified as a digital public good. A digital public good is a international association which identifies different software available in open source domain, which is useful for society, and uh, that comes with no strings attached, right? It could be like in terms of database or software solution or end-to-end system. So Divok has been certified as open software, as you can see listed on their website. So this is a screenshot from e-governance foundation website. This is a bit dated. It kind of quotes about 1 billion digitally issued certificates being used in multiple countries, and kind of it's already implemented in other countries also. And also it has been used for COVID-19 test certificates also, not just the vaccination certificate. Till today morning, it has issued 1.9 billion certificates. That is not including all countries. It's only the kind of one of the implementation. The total is close to plus 10, I mean, 50 million or so. WHO recently kind of came up with the DDCC standard data elements. It's internationally accepted data elements that one wants to see in a vaccination certificate. DIVOC is already compliant with that system. So being open source and being implemented in multiple countries, what it means is like all those countries are compliant with the WHO standard. So kind of it replicates the good effects of being open source and standard compliant. This is one of the code from Linux Foundation Public Health. It's a part of a Linux Foundation. They kind of endorsed DIVOC as one of the open source based solution for COVID based certification. So it all started in 2020, like end of 2020, when kind of you can imagine how the world was going through a lot of uncertainties, and even there were rumors about like vaccination, will it be there or like will it be available in India anytime, right? Anytime soon. So at that time, the concept of dialogue, the vision started with this, like enabling multiple countries to digitally orchestrate a large scale vaccination program. So earlier, you might remember there were a couple of other vaccination programs, but that was done in different phases, not at like this scale and within the stipulated time frame. And using open source digital infrastructure as a public good, so that like it can be leveraged in other countries also.
So, the DIVOC, when it started, any particular vaccination program, usually it goes through 3 phases. So first you see that a vaccine, the first phase would be the vaccine shortage phase, and the next phase, the vaccine in Yeah, I think now it's fine. So there will be, so I'll just repeat it again. So the vaccine program, any vaccination program can go in 3 phases. So the first phase is the vaccine shortage, and the second phase is in which the vaccine is inadequate. And the third one is vaccine where the vaccine is in surplus. So the infrastructure or the system that is being built should seamlessly support these 3 phases and during these 3 transitions. So when we talk about a large-scale vaccination, so particularly when we build a system, so it should kind of orchestrate different concepts. So the first is the vaccine readiness. So then the vaccine storage, then the complete supply chain management comes into picture. So the second thing is, so once for this complete system, you need to also have a complete capacity building, user training, and a proper field support. So the third part is the actual field where your vaccine is getting administration and you need a proper management. So in these are the multiple systems that would be required for a proper vaccination program. So along with this, the fourth phase, where DIVOC comes into picture. So this is where DIVOC comes into picture. So DIVOC mostly concentrates on vaccination certificates and creating certificate access, certificate verification, dashboards and analytics for monitoring, and feedback capturing, and multiple things across all things regarding to vaccination certificates. So this is where the first mental model that we are going to describe about. So that is 80-20 principle rule, or the Pareto principle. So which clearly says that in a particular system, we will have something like 20% of the cost, which plays a vital role in bringing up 80% of its consequences, right? So the numbers might not be exactly 20%, but what it's going to mean is a small part of the system plays a big part in a larger system. So this is where DIVOC also comes into picture, where DIVOC is a small part of the system, but it's playing a very important role in the complete large-scale vaccination program. So this numbers might not, or this principle might not be applying to every scenarios. Like moving on. Yeah. So the next thing we talk about here is the different perspectives to the system. So the first perspective is the beneficiary. So the beneficiary here is the recipient who is going to take a vaccine. So from a beneficiary point of view, so this new vaccination or the digital vaccination certificate should still be allowing the conventional paper-based vaccination certificate. It should be easy to use, and the system should also provide a consent-based data sharing, and it should also be privacy friendly. So then from a community perspective, the system should establish trust between the community, and it should basically, once this DIVOC or the vaccination program comes into picture, the normal activities should, whatever was happening before, should continue seamlessly, and it should encourage community-centered behavior. So the third perspective is the governance. From a governance point of view, so it should enable the economical activities, and it should bring more transparency by bringing up monitoring and also managing the complete vaccination. So then the fourth perspective is the international usage. So from an international usage, the vaccination certificate should enable us to travel across the globe, and using this vaccination certificate, it should help us to bring the trust and the exchange of the data, that is, a recipient is being vaccinated or not. So to exchange this data, so the system should also be able to support that. So now, so this is the second mental model that we are talking about, which says multidisciplinary thinking. So this principle says that, so when you're building up a system, you draw different disciplines or draw different perspectives and think across all through the different perspectives of the system. So this will enable us to build a system reaching different boundaries, and also the solution kind of enables us to solve multiple complex situations.
So with that, like we put the divoc in the center and we saw like from a different perspective. The idea is like in order to succeed, we should kind of cater to all the perspectives, like not just the one. Like if you keep the beneficiary happy, but not supporting governance, the solution will render ineffective. The same goes with everything, like international travel or like maybe it's a community, like getting back to the normal economic kind of growth or activity, social activity that used to be there. I mean, it's hard to kind of think back in time when like lockdown was there and like everything was shut down. Just kind of try to get into that situation. So that's when it was playing a very important role. Now, I mean, if we want to build such a system, right? Like, let's do a kind of back of envelope calculation, right? How does it look like? What is the scale that we are talking about? So at that point of time, there were somewhat like guesstimates around like 1 or 2 doses are enough. And there were like rumors about like it should be carried in a lower temperature, which is like not possible to have it in India and all the stuff. So with that, like we just took a assumption of a 2 dose, which is like kind of max, and then 1.32 billion population of India as one of the example. There are other countries. I mean, if we can cater to India, probably all, I mean, similar countries are covered. So 5 days a week, it's a kind of just like saying Saturday and Sunday being off. Saturday is not off in most of the health facilities, but still we consider that. And then coming with the two into like multiplying this 365 days, like 2 weekends. If you remove, I mean, you come up with the total number, it roughly comes around 10 point some like odd million per day. So that's a vaccination flat rate. If we can achieve that, like we can finish whole India vaccinated in 1 year. So that, I mean, even with this rate, like it takes 1 year. So that's the kind of number we are talking about. So at high level, if you want to kind of code it, like we are looking at like 10 million vaccination per day. And it should work, I mean, at the scale. And also there is a other things at play. Like when we said like scarcity of vaccination, there could be a lot of customization needed, like prioritization of a beneficiary, like based on the age or comorbidity. I mean, a lot of other factors were proposed, and the system should be able to cope up with those and scale only the component that is needed, rather than building the whole system trying to cater to that load. And it should be elastic, and it should be like applicable for the small country. Like if you build like 10 million per day scale, and like we cannot deploy to a small country which needs only like a 10,000 vaccination per day. I mean, from the cost perspective, it should be like horizontally scalable, if we can put it in a tech nomenclature, right? And the vision was like being digital first and system which is agile and responsive. Like it should kind of adapt to the conditions, and like if there is any new requirements or like feedbacks that is coming from the ground level, it should be able to kind of adjust to that. And real-time observability is the key, because when you're dealing with a public system, the transparency brings trust in the system. Like if you simply say like these many are vaccinated and the numbers are not visible in a transparent way, you can't even like whether this certificate can be trusted or not, like whether it's really happening on the ground. So that will be in a question. So basically, what's happening here is like I mean, after approaching two different perspectives of the system, we are taking some ground truth. So this is like first principles at play, where we are seeing the system like decomposed into a non-reducible components. Like, okay, there are like so much of population, we know that, and these are the doses. Obviously, this number should be somewhere roughly around that number. Like, cannot, I mean, could be deviation of some percentage, but it cannot go very much, I mean, wrong, right? So we are just taking the support of the fact to come up with the sizable estimate of the system. And then the next step, I mean, it's not like complete gist of the discussion that happened. This is just a small excerpt, I mean, just to show how kind of I mean, went about detailing the system. So We know that there will be phases of a scarcity of vaccination in the system. And we also know that the certificate can be used for resuming social activity. Maybe it is like an entertainment or like maybe events, marriages, etc. Or maybe economical activities like markets opening, etc. So when such a case is there, there is a good chance that there will be a good value for the proof. Like possessing a proof will have some value for the person. So when that happens, there could be people can put effort to create a duplicate certificate or the fake certificate just to get entry to the event system or whatever. Like I want to watch a cinema and just go with the duplicate. There is a good chance of that. So what we can conclude with that is like it should be secure and you cannot reproduce or like a fake the certificate, right? And also we are saying the certificate should be able to kind of enable the social activity, which means others should be able to understand the certificate. It's not like a proprietary certificate issued, only few authorities can read it, right? That's not going to work. So it should be open specification based so that third party can integrate and leverage the value out of the certificate. So, what can happen if this is true and that is true? People can download and keep the certificate with them probably, and then show it whenever is needed. Or maybe they might download whenever it is needed, and then like if it is like quickly available. So with that model, what it says is there are two characteristics that we are looking for. Maybe we can go with a lazy approach. You get vaccinated, that's fine, and you can access the certificate at a later point of time. So that's something, the fact that is coming out of here. And the other one is like access should be very easy in order to make it more effective. Otherwise, it's going to defeat this purpose. So similarly, there are like, when we are working on this, there could be many others implementing similar solutions. So possibly other country can have alternate mechanism or like other standard. So it should be able to interoperate with that. Otherwise, it defeats again the building a common trust between different countries, right? So basically, we just took certain scenarios, not an exhaustive one, but what I'm trying to demonstrate here is like second order thinking is at play. Not necessarily second order, it can be multi-order. Basically, what we are doing is playing out then what scenario. We know some facts, so we can deduce what happens next and then see what happens next if that is both are true. Like then we can just build a binomial tree kind of thing and then come up with the scenarios and certain probability of occurrence. So with that, we can say it should be secure and trustworthy. It should be consumable from the system integrators. From the tech angle, to be API based, open, and like commonly understandable, and like maybe some authenticity or authentication mechanism to allow the access. It may need multiple integration, ability to export it in different formats. If different countries use their own formats, it should be able to kind of convert it to that. A system may need to support plug and play components to kind of, let's say, if you're talking about a multiple country scenario, the kind of name, address, etc. varies. So there could be a small customization required for the country level. So should be able to kind of add a small pluggable component and support it. So also, we noticed that there is a usage pattern. Probably we can leverage that in the kind of going about system design, right? There is a vaccination and then they access it within the, before that they forget it, probably 1 or 2 days, and then probably they use it. So if we use this pattern, we can probably better design the system, probably use a cache which kind of lives for 2 days or something. Okay, so the other way to look at the same problem is, since the problem is very kind of connected with a lot of moving components, and we need to kind of cater to 4 perspectives that we covered. So it's one of the way to kind of see the problem from other end. Think of the points that can make the system fail, right? So we are trying to see kind of, if you think about it, like if it's a digital solution and it requires a mobile, then we are dependent on mobile penetration. Like who are not having mobile cannot use the system. And authenticity level, if it is doubtful, let's say it's a paper-based certificate signed with someone, right, which doesn't have any trust associated with that. It could be printed with the digital system, but it doesn't have a credible proof. That will leave the system in kind of unusable state, because the certificate that is produced may not be authentic, right? So no way to assert the authenticity of the certificate across countries, right? I mean, if there are like every country is using their own custom format and there is no way to validate the proof, then it's going to render it's useless. Similarly, I mean, certificate, the ability to understand the certificate becomes very crucial. And if it works well, but it's highly secure, but we cannot issue so many certificates, right? We are talking about like a 10 million per day, but we cannot do it, right? So even that leaves the system unusable. I mean, even how, I mean, whatever the security that it is providing, it is not able to cater to the scale, it's going to fail. So similarly, I mean, country needs a lot of changes. Let's say if you're going from India to Bangladesh, where Bangladesh is not a centralized system like India, where there is no central ministry of health, it's block level. So the chain that works is quite different. So if you're making any dependencies on the country structure, it's going to fail. So it brings out like it should be highly configurable and like taking a minimalistic approach where it can kind of cope up with the changes that is needed at the country level. And but the implementer, a very important thing is like to see what is going on the ground, like process, right? If you cannot see the progress, even if you digitize, there is no return for the governance perspective. So this is one of the key things, uh, how the system or program is running on the ground. Um, and also, let's imagine we come up with a highly secure digital system, but it needs additional 5 minutes after vaccination. It's going to add an overhead. It's kind of complicating the current process. So it questions the effectiveness of the solution. So basically, when we think like that, like we can come up with the architectural criteria that we already kind of discussed or touched upon. The mental model at play is like an invert. So when the system is very complicated, you approach from the other side. I mean, if we might have done it in the multiple choice questions, right? Like eliminate one, and the one left you cannot eliminate is the answer. So somewhat similar to that. So it kind of brings out the characteristics that we are looking for.
Now, going back years back, so now when vaccination, how was it happening 2 years back, right? Any vaccination, when a person gets vaccinated, there was just a paper receipt or a paper that was being provided to the recipient. So, the complete paper, the complete vaccination certificate becomes legit only when a facility signature or a stamp gets printed on it. Uh, then there was, so this vaccination certificate was not centrally validated, right? So there was no central authority or someone who could say, okay, this is a proper valid certificate. And this particular vaccination certificate, it to not have a proper um, the data that was being captured. There might be something that was not required also. Something you can see here is, so there is a field called date of birth. So from a medical standpoint, you don't need date of birth for a vaccination certificate. So just a year of birth is more than enough from a data perspective. But still, there is a lot of data that's been getting captured. So for an example, we are specifying that date of birth. Similarly, there are multiple data points that gets captured without a valid requirement.
So this was a standard published by WHO in 2006 and like being used for other vaccines. Like if you would have used like for yellow fever vaccination, etc. It was used in a limited capacity, so that was okay at that point of time. And like it actually mentioned the official stamp of the administration center. So basically, you have to take the rubber stamp and the signature valid from and the manufacturer of the medicine, etc. But I mean, imagine if you kind of travel to other country, what is the way like you can trust that stamp, right? So I mean, the problems were evident, but since it was done, I mean, it was in a lower scale. There was a trust built upon the physical certificate.
Yeah. Now, we are going from paper-based vaccination completely a digitalized vaccination certificate. So for this, to make it digitalized, so we followed W3, a verifiable credential. So when we see a W3 verified credential, it takes you can see the life cycle or how a particular gets generated. So there is a issuer component. Basically, the issuer might be a facility or an hospital in general is going to issue a vaccination certificate to the holder. A holder is a recipient here. So that holder can use that or a verifiable credential and get it verified in other places, might be airports or in different places, and the complete will be stored in the registry. So talks about so so our VC what we built in DIVOC follows W3. So when we say W3C vaccination verifiable credential, this is how a sample VC like. So it has three parts. The first part is the credential metadata. Basically, credential metadata stores the basic information about the recipient, who the person is. So it will be very minimal in nature. Only the required data points will be captured. And then the second part is the claim. The claim actually stores the evidence or the point in time when the recipient got vaccinated. So this evidence stores vaccine information and the facility where he got vaccinated and when he got vaccinated. And the third part is the proof. So this proof captures the cryptographic information about this complete record. You could see that there is a proof record in this sample. This stores the algorithm and the actual signature will be stored along the complete. So here we talk about the combined effect model. So which says that 1, 2, 3, which along with summing up together is greater than. So which says that when we have multiple processes, combining them gives us a better value, significantly greater than their individual value.
So with these all models, we kind of summed up this architectural criteria. We kind of saw it in multiple other slides. It's kind of listing all of them in one place, not really covering all of them, the high level architectural criteria that we are looking for. It should be backward compliant because the laws cannot change overnight. So we have to kind of comply to 2006 standard that was published until the next standard becomes available. So there should be a paper copy which is having the similar data elements for kind of to be able to kind of travel and be accepted internationally. Should be interoperable that we already discussed. Adoption, I mean, if there are two countries, they should be able to kind of convert it to their own format. Scalable, it's no additional I think we talked about. Flexible and configurable, it's both because of the data and also processes, like there could be additional steps required in different countries. If it is public health facility, if it is mobile van, there could be different steps because it works in offline. They go somewhere and like vaccinate and come back. So the processes might change. However, if we can give the unified vaccination API, which can cater to multiple mechanisms, right? That can kind of help in different scenarios. Observable, which gives insights into the system, like how many vaccinations, where it's happening, what's the age split, kind manufactures plate, all that, like, and it should be resilient, of course, like, because when vaccination happening, because system is not available, I cannot stop vaccination. The intent is vaccination, the system should just assist it, right? And leverage the industry standard from the privacy and security point of view. We have already established cryptographic standards like known algorithms, which are good enough to support current computing capacity. Obviously, it can go out of standard at some point, but we will kind of leverage the existing one. Open standard like W3C are constantly standardizing some of these, like they're sitting drafts and like taking feedback and kind of publishing those. We leverage that. Trustable, it should be clear and open implementation. I mean, what I mean is like, even if it is open, if there are no SDKs or samples given, the consumption from the third party will kind of get bottleneck. I mean, it gets limited because of that. So unless we do that, we'll not solve the first problem of the getting back to the normal state. So internationalizable, obviously, we have like a lot of languages. That is one aspect of it. The other aspect is like address formats and the names. I mean, if you go to European countries, they have like two names. One is in English, one is in local language. Both should be there if you're traveling. All that like complications. API and integratable, like we know what it is. And it's like standard is current, like REST is flying. So REST should be at least supported, and OAuth-based authentication. Minimal. This is like, we try to remove any component and see if it still works. Like minimalism, fundamental design criteria. So we try to remove any data element which is not required in the certificate, including the date of birth, having kind of date and a month. Only year is suffice for, say, the age. What is the age? Because age is required in kind of treating adverse reactions, etc. So that's like a required element. So with that, we'll, kind of can discuss a little bit on the certification architecture, like a little bit of technical implementation of it, right? We talked about the vaccination API, REST-based, being open. There is a Swagger open API spec, and like it just implements that. OAuth-based authentication. If you have a client issued, you can just use your token and like call those. We, again, use the key clock, which is open source security authentication software that's readily available, and JWT, public private key based JWT, so that like you can take the token and go out of system, so that we don't kind of bottleneck this key clock. This vaccination API can independently authorize and like take the requests, and dump into the Kafka. So even before we do anything meaningful, just the basic validation of the data and keep it in the queue, so that we don't lose the resiliency and failure due to any subsequent system failures, right? And yeah, next. From the Kafka, basically there are multiple consumers. For the simplicity, I'm just taking the signer component, which is important from the certificate point of view. Signer is the one which kind of takes and validates and adds a kind of signature, the RSA-based 2018 standard signature that we saw. And it stores in a Sunbird RC open source registry platform. It's a customizable schema-based registry. It has a multiple backend options. We use the Postgres with the multiple replica to just to make it highly available. And so parallelly, we have an analytics feed, which kind of it can work at a different pace, so that like it aggregates and gets statistics in the analytics database. We leverage the ClickHouse column-based database to come up with the high-level stats, right? It can like do a lot of aggregations, etc. And so here we saw a bottleneck as a concept again and again, like in multiple scenarios. It's one of the mental model which says like in the pipeline, if you have a weakest link, that is going to determine the system characteristic. So there are multiple ways to deal with it. Like you can add a parallel pipe, or can just remove that link altogether if it is possible without leaving the business process in inconsistent state. So that's what we did. In this case, getting a vaccination certificate is not a necessary a task for taking vaccination. So we just took a lazy approach, delay it until it is needed, right? So that helped us to kind of remove that bottleneck altogether from the actual business core function. It's part of the system problem. We should still address it, but we can take a little bit of time to generate or like make it available. However, we cannot constantly be lazy and like say, okay, we'll do it at the constant pace, like maybe 10,000 per minute or second or whatever, and build a big backlog, right? So we should be sensibly kind of adopting to the scenario. What happens here is there are a lot of signer components, and there is a measurement of like what is the capacity that is required on demand, and then it scales based on that, the number of signers it's required, and then like it just consumes more and more certificates, I mean gets generated, so it will be able to adopt. But there could be a delay in a minute or second, right? So it's not like an indefinite delay, but it's a known delay. So with this, like we're kind of using the feedback loop. It's applicable in the business also and technology, I mean, technical solution like this. Generally, we use like autoscale, Kubernetes based, which actually doing the feedback loop. We can set the probes on the CPU or the like input request rates, and like it kind of gives the feedback to the system, can spawn more pods and like allocate the resource to consume more. So with that, like we can say like a kind of an elevator pitch of DIVOC. It's a flexible, extendable software. Probably it's like we already discussed the rest of, explanation that helps countries to digitally orchestrate large-scale vaccination certification using open source technologies that is standard-driven, scalable, and secure.
Talk about DIVOC. DIVOC consists of mainly the modules that DIVOC what we built. So the first module is the field orchestration module, so which basically concentrates on the field management, building the facility, managing the vaccine, allocating the vaccine, all of that. And the second module is the main module, which talks about the generating the vaccination certificate. So the third module is the citizen feedback module. So basically that module will be for capturing the feedback once the recipient gets the vaccine. And along with this, we also need a module to capture the analytics. So this brings up the monitoring aspect across all the modules. It shows the different metrics around how much vaccines have been used, how much is pending, and also state-wise, national-wide counts across vaccination certificate. And all of this will be stored as a register. So that is the next module here. And at a high level, this talks about the system details of what DIVOC does. So we have our major modules on the left-hand side. It could be the vaccine storage and supply, capacity building, and administration. So the major layers or the users of the system are, so once the first thing is the facility. In a facility, we'll have vaccinators, and the vaccinators will have the facility along with the vaccinators have the vaccines. So the recipient goes into a particular facility, gets a vaccine by the vaccinator. So this particular metadata or the record is being captured and being sent to the system. So this complete data combined together then is we form the vaccination certificate. So when we consider the data inputs to create a vaccination certificate, from vaccine, we capture what is the name of the vaccine, what is the manufacturer, who is the manufacturer, and what batch code the particular vaccine was taken from. And from a vaccinator, we take information like who's the vaccinator and whether the vaccinator was certified or not. And from a facility, we capture which facility it is and where it is located at. So from a recipient point of view, we capture the name, age, gender, and an identity. So for the identity, so we have been following another recommended format from W3, which is the DID format, decentralized identifiers. So this helps us to store various identification values in a simple single field. So once the information comes into the system, so we build a verifiable credential, and that particular verifiable credential is stored in the registry.
I just want to kind of add on to this, we kind of about this QR code. Um, Really what happens is when you scan a QR code, you go to the link which actually proves the fact. Instead of that, here it is a self-contained artifact. What it means, like you can fly to other country, may not have access to the government infrastructure on the actual certifying country. So you have to kind of carry along, just like what you used to do in the paper world, right? So I mean, we talked about the combined effect. So you're taking the trait of carrying self-contained what you own along with you without compromising the secure signature that comes along with that. It's kind of evident, but I just wanted to call out like, because most often it is used as a link and like it connects back to the world. And decentralized identifier, just to kind of get like a little bit background, it follows DID as a schema in the URL format, like HTTPS, that like if you use DID. The next fragment kind of resolves to the system that authorizes the next part of it, or like who understands. So there can be multiple resolvers. I mean, just to kind of put it in the perspective, right? Like you can have a PAN card or like a elector ID. So if you say PAN colon PAN number, like PAN system should be able to authoritatively say whether it's a valid or like what it resolves to. And it's not necessary that like it should resolve to unique artifact. I mean, it's just the subject is claiming that this is my identity, right? So by using this, what we are trying to do is like it is kind of compliant for multiple countries. Like I cannot say SSN or like elector ID or any kind of known identity. The country can configure what are the resolvers that they want to support. Like they might have Aadhaar, which is not there in any other country. So they should be able to kind of plug in those resolvers and validate. And this part, I mean, this talks about like ability to export it to multiple systems. Like it could be like a digital wallet, like iPhone, just import it to your health wallet. Though the standards are not like still, I mean, completely worked out. There are like parallel efforts going from device vendors. Like Google has its own standard, Apple has its own standard. But at end, when they kind of converge, they should be able to integrate easily since the spec is out there. It's already integrated with the locker, um, and the print is anyway known.
So along with that, so once the verifiable credential or the vaccination credential is created, so this particular, yeah, so the next thing is we capture the complete analytics around it. So which says about how many people have got vaccinated and where they have got vaccinated. So, and at the, what is the rate at which the vaccination is happening. And also we also capture about the feedbacks from the recipient. So once he gets vaccinated, is there any adverse effects? System also allows the recipient to submit those adverse effects. So that is the feedback system. And so the next system is the verification. So we also have a module so where a user can scan his QR code and get it verified. So, so this particular library can be used by any third-party providers or service, and they can verify the vaccination certificate completely offline. They don't need to connect to this main system to verify that certificate because the QR code self-contains the. So to generate the verifiable credential, we would have used the private key, and the public key will be shared with all the publicly accessible, so they can use the public key and try to verify the QR code or the verifiable credential.
Yeah, open discussion. Yeah, whatever you see in the PDF, all the data elements will be available. Okay, the question was, um, so what is there in the QR code? If I kind of, it's a JSON, I mean, the format, yeah. The question was about what is the format and what is there in the QR code. The JSON's example that we saw in the earlier slide, the same JSON is packed and compressed and put it as a blob in the QR code. So yeah, I mean, it contains all the information what is visible on the page. Um, Probably I'll just, okay, so it talks about anonymized analytics. So it's not like after the fact analytics is anonymized. It's not like you have all beneficiary information we are trying to analyze without caring about the mobile number or name. Basically, the feed that goes from here, it drops any personally identifiable information so that the system itself, by design, it is privacy centric. Um, so no matter, even if it is compromised, you cannot make any traces back to the person. I mean, so that is like privacy at the design level. So with that, like there are some of the uh, key kind of qualities of a vaccination certificate.
Yes. Talk about the vaccination certificate. The vaccination certificate had to kind of, we have followed the complete WHO guidelines provided. So based on that, we created the W3 schema for it. And so along with that, the certificate should align to the FHIR or the ICD codification. So the authenticity of the certificate is completely stored as a digitally signed QR code. Anybody can scan the QR code and using the public key, they can verify it. And also the certificate should be digitally available so that you can share it across third parties digitally. And also for non-smartphone users, also provide them a printable format so they can, this certificate could be printed and then can be used. And the certificate also needs to be multilingual. So like in India, so we have people talking in different languages. So the certificate should be printed in different languages also. The system should be able to support that feature. Along with the downloading or printing the certificate, so the user can also can connect to different third parties and can give them a consent to use their vaccination certificate. So for example, you're booking a flight ticket or anything, if they want to know whether you're vaccinated, so they can take your certificate ID and you can give them the consent. Once the consent is provided, they can download the verifiable credential and make sure that you are actually vaccinated. So the vaccination certificate also needs to be connected with all the e-lockers. So right now, lockers and other lockers have been integrated. So then also along with that, the privacy also needs to be protected here. So and also the vaccination certificate had to be customizable based on different needs because countries have different requirements and this uh, component needs to be customizable so that we could support their requirements.
Yeah. Okay. Yeah, the question was how it was integrated with the appointment system and whether the ID, which a decentralized identifier, helped in integration. Yeah, I mean, from the beginning, as we saw, like there are three components. One, like the supply chain management, and then actual facility administration, treated as an independent module. And any third party or existing system should be able to kind of hook into the vaccination certification whenever it is required, which is at the end of vaccination event. So it is a one call out and standard based API. So, I mean, it was easy to kind of call out that like at the end of vaccination event. You take like, there are other standard, I mean, open medical record systems available. We had like one of the integration in Lanka, which third party open source medical record system calling out to the vaccination same certification module without any change because it's standard again REST based. Yeah, definitely DID addressing of the identity helped a lot because it doesn't make any assumption about the country or like what kind of format the ID, as long as the resolver is able to kind of add value or like a resolve to the actual identity. Okay. So the question was, are there any particular cryptographic algorithm used for securing PII? The cryptography used is for signature, not for encryption, because the certificate is the artifact you want to present it to the third party. When you present it, they should be able to read it. So it's a ability to assert that the proof is from actual authorized person. So that's the intent, not to encrypt it. But from the privacy point of view, we omitted any information that is like compromises the privacy and not required by standards. Like the date of birth, we made it like year of birth, but I mean, in the standard domestic certificate, you will see only age mentioned, not really the date of birth, because many other system uses it for challenge for security, and then it can compromise. So, but name you cannot omit because you need that as a kind of artifact. Right. Yeah, I mean, it comes with, together. Okay, the question is like PI rules for country is different in different kind of territory. Yes, that's true. But there is also standard for vaccination certificate, which is from the international body, WHO, which talks about DDCC, the initial, the data element that should be part of a vaccination certificate. So as long as that is mentioned there, the vaccination certificate becomes a PII artifact. So having a PII is not an issue since it's a part of the spec, right? But yeah, cryptography at play is to prove it, not to encrypt. Yeah. The question is like, can I kind of modify any of the data in the certificate and still pass through the verification process? I understand. Yeah, it's possible. It might take like many thousands of years with the current computation capacity. I mean, based on the cryptographic algorithm that we are using. Yeah, but practically it's impossible. All SSL certificates currently you're using, when you go to google.com, if it says like log, it's using basically the same technology. Uh, yeah, I mean, basically, whatever the blob is, it runs, I mean, the private key kind of gets a checksum equivalent of it, and then that resultant tie is put into the signature. So, I mean, by definition, if anything changes, SHA should change. I mean, if it doesn't change, then it's problem with the algorithm, right? It's just talking about like, the same certificate can be kind of presented in, I mean, different delivery channels and like representation formats, um, including one of them being printable. And Common Pass is one of the standards that was evolving in the travel industry. There is another one also. There are like multiple standards, interchange format. That like just to summarize from mental model perspective, which actually the one of the core theme of the this discussion. Um, we kind of touched upon 80-20 rule. So we might have to focus and ask question when we are trying to analyze some of the problem. What is the most important part of the problem that you want to fix without compromising needed kind of characteristics of the system, right? So, and multidisciplinary thinking, like I mean, wear different hats and see what is important for them, like a role play probably, and just check what is crucial. First principles, never go away from the ground truth. I mean, it should be kind of deducible and like supported through uh, the basic components of the problem. Second order thinking always helps. So you implement one thing and like what happens if you implement thing. I mean, that there is a interesting story about the cobras in Delhi in the British government. You can just Google and see like multi-order effect, like how is it in play. It also kind of get part of the gamification. Inversion, you can see from the other side of the problem and try to break the solution. Just try to avoid that. You will be kind of successful. That's what it's trying to say. The other way is to kind of, when everything is known, you can say, okay, you do this and this will be successful. But when you don't know, there are like multiple actors and scenarios at play, you might have to take this approach. Combined effect, as we saw, there's I mean, different artifact. We are just combining the cryptography and the paper-based, the freedom that you get with the paper-based certificate and the cryptography and also the trust among the society. I mean, if you see, the money is basically the same, right? I mean, it's just the belief that like, oh, it's so and so, I mean, worth of value. And if the other person believes, then only it's meaningful. Same is true for the certificate also. Just that like you can get like 1 million more value. Bottleneck, we kind of discussed the kind of limiting factor in the system, try to get rid of it or improve around it. There are multiple approaches again. Only two I mentioned, one parallel, one remove. There are like other like a partial hybrid approaches also. Feedback loop always helps, whether it's technical or personal, and that's why you're looking for feedback. Like any feedback, just put it in the question or like probably mail that. Yeah, the question was when I kind of use this solution, whether it comes with the infra and like probably the all components also. So the answer is no. From the beginning, we kind of considered vaccination module as independent, and also we do have a registry facility and like vaccinate. Each of them are like from the beginning designed as an individual deployable component, a so-called microservice these days, maybe change over time, like used to be a business service earlier. So some logical unit that does a meaningful business work and leaves the system in consistent state, right? So that's the definition. So vaccination API, such one independent module can be used independently, but the solution comes with the infra support, infra as a code, support for Docker-based deployments or Kubernetes-based deployments. And like the configurations are tested well enough with the performance test, etc. So it's like easy to bootstrap and implement the countries. We had like one or two implementation took a while, but like further country implementation used to take like 3 to 5 days of like effort. Yeah, not really help me. Even the exact YAML files we have, you just go and apply most of the time it works. I mean, if you have the customization that you have to do. Not necessarily. I mean, Kubernetes not necessarily mean cloud. Kubernetes, you can have its own cluster. In fact, I mean, multiple countries are using private cloud, the bare metal based Kubernetes cluster. And not, I mean, Kubernetes is not the only way. I'm just saying that is easier way because you have well tested infra as a code. No, I mean, at the end, like microservice runs anywhere. Like you can run it on the bare metal. But yeah. These are some books like that might help. Talks about a lot of mental models. Most often we use the mental model, but may not attribute. But yeah, if you have that knowledge, you can kind of, effectively use it rather than like really thinking. 300%. Yeah, I mean, since I kind of, okay, the question was, since we are talking about the scale of 10 million a day and 300 per second, which is like an ideal load, since we know also there is a mental model called bell curve, and the traffic pattern usually shapes a bell curve. In the morning, people are lazy, they're not coming that much. Around 12:30, it gets like a peak, and then after lunch, it gets again one peak. So and then goes down. So that's the traffic pattern we saw. In the peak, it's far beyond 300, and system was tested for like handling 2x of 300. And since it is auto scaling, it just a matter of spinning another signers, like I mean n number, whatever is required to kind of consume those backlog. So yeah, I mean we saw like two I mean 5 minutes kind of a gap between the delay between like creating a certificate in the peak 12:30 around. But once it scales, like it just goes at whatever rate. It's independent. Okay, so the question is like, is it independent implementation for individual countries? I mean, it is independent installation because of not just the data or technical reasoning. There are most of the countries have a law saying their data should not leave their territory. So same is true in India. So it's like because of that law, like enforces it, have it in-house data store. House in the country. That, that's all right. Thank you. Thanks for your attention. The next dev day, I think Karun is going to kind of, 21st is the next.
Okay, so thank you everyone for joining. Trying to do events every month. Unfortunately, next month has a bunch of long weekends. We try to do close enough to Friday, end of the week, not quite Friday mode. Unfortunately, next couple of Fridays in Maharashtra is a day off, so kind of hard for people to come in after work. So which is why we are not doing it on the 4th than we had originally planned it. Next event is on the 21st, where we will have an external speaker coming in. His name is Peter, who's the director at Imply. He's talking about Apache Druid next time. So this talk is going to be online because Peter's not in the country. But the one right after that is back in the office. Cool. Thank you everyone for joining.